My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Not Drug-like, but Like Drugs. Cnidaria Natural Products. This research focuses on Cnidaria-derived natural products. Phylum Cnidaria, or broadly speaking corals, anemones, sea pens and jellyfish, is of interest as the second largest source of marine natural products. Cnidaria natural products are chemically diverse, and include toxins and venoms, terpenoids, diterpenes, prostaglandins, and steroids.
Phylum Cnidaria has been an excellent source of natural products, with thousands of metabolites identified. Many of these have not been screened in bioassays. The aim of this study was to explore the potential of 5,600 Cnidaria natural products, using a systematic approach based on chemical space, drug likeness, predicted toxicity, and virtual screens.
That is so intriguing, Boson. Cnidaria natural products overlap with drugs and toxins in this chemical space, although a multivariate test suggests that there are some differences between the groups. In terms of the established drug likeness measures, Cnidaria natural products have generally lower quantitative estimate of drug likeness and relative drug likelihood scores than drugs with a higher prevalence of metabolites that exceed at least one rule of 5 threshold.
An index of drug likeness that includes predicted toxicity, however, found that Cnidaria natural products were more favorable than drugs. Overall, the study concludes that Cnidaria natural products have good drug likeness profiles and provide a diverse range of metabolites for future exploration.
That is a very interesting observation, Boson. What is interesting is this. In the current study, researchers were able to identify candidate ligands for cancer-related proteins. Virtual screening against cancer-relevant targets found wide evidence of affinities, with glide scores less than -7 in 19% of the Cnidaria natural products. That was an interesting paper. Hope you liked it, Boson.